Okay, it says, so the rate, oops, wrong button. So the rate at which rainwater flows, let's get a different size on the pen here. Okay, the rate at which rainwater flows into a drain pipe is modeled by this function R. So R is a rate, and it is the in rate. Cubic feet per hour. Time period is 0 to 8. Pipe is partially blocked, allowing water to drain out the other end. So it's exactly the same kind of situation they often have, where you can just think of it as a tank of water, even though it's a pipe, and there's a rate at which water flows into the tank, and then there's a rate at which water flows out of the tank. This is the rate at which water is flowing out. There are 30 cubic feet of water in the tank or the pipe at time equals 0. Is the amount of water, not rate, is the amount of water in the pipe increasing or decreasing? So it's Danica's chart. So I think to myself, okay, so I tell the grader A of t is going to equal amount of water in the pipe. So A of t is the amount of water in the pipe. So here's the amount of water in the pipe. And then I think to myself, Danica's chart, the amount depends on the rate. So I've got to figure out if the rate is positive or the rate is negative. Then I'll know whether the amount is increasing or the amount is decreasing. So I remember this. My amount is A. It means my rate at which A changes is A prime. And A prime is simply, this is off the golden notes, my in rate subtract my out rate. So I write that down. So A of t, A prime of t, is going to be the in rate, capital R, subtract the out rate, d of t. So I'm supposed to be finding out what's happening at time equal 3. So I write on the paper A prime of 3 is going to equal R of 3, subtract d of 3. This was originally a calculator required problem on an AP test, so they did expect you to use your calculator. You can use the calculator this year as well. So here's my R of t, here's my d of t, and so I simply did the computation on my calculator. So I write A prime of 3 is equal to negative 0.314. Is the amount of water in the pipe increasing or decreasing? Give a reason for your answer. So the pipe, the rate is cubic feet per hour, so this is cubic feet per hour. Now I can give an answer. Since A prime of 3 is negative, A of t, see, I've already told the grader that A of t is the amount of water in the pipe. A of t is decreasing at t equal 3, and I always want units, hours. And the way they give points for this is if you show that you have, you come up with this number. This is 1 point for the number right here. So getting this gets you 1 point. Having this phrase, that gets you a second point. So that's also a point. Now, you can solve the problem in a different way that is just as logical, it's just different. You could also simply say, you go find r of 3, so tell the grader r of 3, and you use your calculator. This is what I did here. This is r of 3, 5.086. Try to remember all these units just in case. Plus it helps me understand the problem better, cubic feet per hour. Then I go find d of 3. So that's going to equal, that's this one, 5.400. And then you say since. So if you have these two numbers on your screen, on your paper, they're going to give you 1 point because they realize you knew you had to find those. Then if you have on your paper this phrase, since, let's see, d of 3 is greater than r of 3, the amount of water in the pipe is decreasing. This time I would have to write out the word amount of water in the pipe because I didn't define a variable a. So the amount of water in the pipe is decreasing. And if you have this phrase, they would also give you the point. So that's a second method of solving this particular problem. Either method is fine. So.